In this video, we're going to continue our discussion of object orientation. At this point, we've covered objects 1 and objects 2, and we're going to dive into the topics of this PowerPoint, which I call Inheritance 1. So we're going to start talking about inheritance. And then the next PowerPoint has to do with polymorphism, so that'll get into some more advanced features of inheritance, but we'll start small with inheritance. And you'll also notice that in the code examples, I have a zip file here for inheritance, and this is going to contain some classes. It contains a package. Let me open the zip file up. And there's a folder here. There's a package that I call inheritance. And within that, there are a few classes. One is the circle class, basically the circle class that we had been looking at before. A couple of classes called cylinder 1 and then cylinder, which are going to be subclasses of circle, and then this test cylinder, which is the driver class. So if I go into Netbeans, now that I have included inheritance within my project, and here's our circle class. You can see it has its constructor, its overloaded constructor. It's got its getter and its setter, the accessor and the mutator. It has its findArea. It has its private member variable called radius. Everything is instance in this class. So this class doesn't include the static stuff that we went over, but it has basically what our original circle class had. And then we'll see that there are these two subclasses. One called cylinder 1, which is kind of what we're going to use to get started with talking about it. And the other called cylinder. We'll flesh it out a little bit more with something that has a little more depth to it. And then there's also this test cylinder, which is our driver class. That's the one that has the main method. So the classes that are instantiable are circle and then these cylinder subclasses, which we'll get to. So here we can start with what's the PowerPoint is showing us. As you can see, this material corresponds with Chapter 11 stuff from the textbook. So what's inheritance? The idea of superclasses and subclasses. There's a notion that we have categories and things and subcategories of things. So when we were talking about the circle class, that was a category of circles, each of which is going to have a radius, for example. And so you can have superclasses and subclasses, very similar to what you learned in the database class with ER modeling, where you had entity types, and there were supertypes and subtypes, same kind of an idea, such that the subclass is going to inherit the members of the superclass, or sometimes called the base class. So that means any instant member variable of the superclass will also be included in an instance of the subclass. So the subclass is going to have its own member variables. It's also going to have the member variables of its superclass. And in fact, if there was an inheritance hierarchy where one class is a subclass of another, which in turn is a subclass of another, which is in turn is a subclass of another, this class that's at the lowest part of this hierarchy is going to inherit all the members from all the classes up the ancestral chain. So what that implies is that an instance of the subclass, memory-wise, size-wise, is going to be at least as big as an instance of the superclass, because not only does it have its own members, but it's also going to have the members that were inherited from above, the member variables. Another thing to note is that an instance methods of the superclass can be called with respect to an instance of the subclass. And that's one of the very nice things about having subclasses, that we can reuse, make use of already existing functionality without having to basically reinvent the wheel. So how do we do this in Java? Well, first of all, there's a keyword called extends. So when we declare a class, we give it a name, and we will also indicate, if this happens to be a subclass of something, that it extends that other class. In other words, when we say class A extends class B, that means that class A will be a subclass of class B and will therefore inherit all the properties of class B. We'll also look in our examples at some more use of the word this, the keyword this. Remember that all instance methods have a this pointer that's pointing at the instance for which it was invoked. And I think I showed you before that I can use the this keyword if I'm referring to member variables. I often don't have to do that, but sometimes there might be a case where I will need to do that, and I'll show you an example of that as we go through these slides. And then there's another keyword called super. It refers to the superclass. We're going to use it in at least two contexts. One, in the constructor of our subclass that we're creating, we may want to invoke the superclass's constructor, and we can do that using the super keyword. And the other thing that might happen is that once we start working with overriding, and we may create a method with the exact same signature in the subclass as exists in the superclass, but if we want to then explicitly use the superclass's version, we can use the super keyword to access that. And we'll also see examples of that when we start talking about method overriding, which is not the same as method overloading, as we'll talk about. And then finally, another thing to note is that the subclass can access any non-private member of the superclass. In other words, anything that's public or protected of the superclass, but certainly can't access private members because only within the class can there be access to those private members. By the way, to point something out, when we did that very first test simple circle, and we had simple circle and we didn't have any visibility modifiers anywhere here. And what does that mean? They were protected. They were not private, they were not public, they were protected. So if you don't specify either private or protected or public explicitly in members of a class, then by default they're going to be protected. Which means that those are accessible from inside the class, just like any private member would be, but they're also accessible from other classes in the same package, which was why in this example test simple circle could access the radius because it was protected. It's in the same package as simple circle. Or also protected members can be accessed by subclasses of a class, even if the subclasses are not in the same package. So in this example, we're going to have the superclass, which is a circle. It's going to have its own methods and its own data. We already saw those methods, and the data was basically just the radius, right? And the subclass instance is going to be able to use all of the methods from above, and maybe have its own, and will also include all of the data from above, and maybe have its own as well. So here's our first example called cylinder 1. So in this example, you can see that we have our class circle, and we have our class cylinder 1 actually, and there's the word extends. So that means that an instance of cylinder 1 is also a circle. So it's going to inherit all of this stuff from circle. Notice also here was the use of the super keyword in the constructor. So you'll notice that the very first thing in the default constructor of the subclass is an invocation of the superclass's constructor. Basically, the subclass constructor is calling the superclass's constructor, but this is how it's done. And similarly for the overloaded constructor. Actually, in principle, if I wanted to, I could have the overloaded constructor just called the default constructor. I could just have it called super without the parameter, and it would invoke the default constructor. Or vice versa. I could have the default constructor called super and pass a number, and it would call the overloaded constructor of the superclass. So that can be done, although it's not being done here. And then here we have a situation where we're actually making use of the findArea method of the superclass in order to calculate the volume of the cylinder and the subclass. And as it turns out, the volume of a cylinder is equal to its area and its length. And why repeat the calculation for the area? We already have the calculation for the area, so we just make use of what already exists. One of the beauties of inheritance is that it allows for code reuse, and we're seeing that happen right here. Another thing to note is the use of the this keyword here. Now notice what happened in both of these methods. We have a parameter called length, but notice we also have a member variable of the class called length. And previously, we used to think that, well, you really can't have the same name within the nesting hierarchy. We saw that when we were looking at scope of variables. But when it comes to member variables of a class, there's nothing stopping you from having a member variable of class and either having a local variable or a parameter of a method in that class that has the same name. So how do we distinguish? How do I know when I refer to length that I'm referring to the member variable and not the parameter? And the answer to that, it's through the this keyword. So that's what made this explicit. If in this code right here, I just said length equals length, then all I'd be doing is taking the value of the parameter and sticking it right back in the parameter. That's not going to do any good. So when I say this length equals length, then that's taking the value of the parameter and putting it into the member variable of the class for that instance. And we see the same thing happening in mutator method here as well. Of course, we could have just used a different name for the parameter, and that we wouldn't have to worry about using this dot. But if we do use the same name, then we have to use this dot in order to make sure we're specifying the member variable. And here in the tester, we're invoking the constructor. We're creating an instance of this cylinder1. We're invoking the constructor. Then we're going to display some information on that new instance. So we're creating an instance. We're going to have my cylinder, which is a local variable of the main method, which is going to point to this instance that we've created. And here we're using the subclass. We're calling subclass methods in order to access the length, which there's no such thing as a length of a circle, but there is such thing as a length of a cylinder, or the volume, and there's no such thing as the volume of a circle either, but there is a volume of a cylinder. And then we're also making use of the superclass methods via an instance to the subclass. So the subclass, which is a cylinder, it's also a circle because it inherits everything from circle. So I can call getRadius or I can call findArea, and therefore I can make use of the inherited members. So let's see it happen in the code. In our main method, we're about to create an instance of the cylinder class here. We can see we have our variable, my cylinder. We instantiate the cylinder object, and notice what the cylinder has. It has a length, and it also has a radius. Again, to illustrate that in the code, here's the length of a cylinder, but because it inherits from above, it also has a radius. So the cylinder1 instance has been created on the heap with these two member variables. And the cylinder1's overloaded constructor is invoked. Look, we passed two actual parameters, so it's going to be the overloaded constructor that gets invoked. So it will have a local radius and a local length, right? And it also has a this pointer. Remember, all instance methods have a this pointer, which is pointing at the instance for which they were invoked. So if it's a constructor, it's this pointer is pointing at that new instance that had just been created. And look what happened. By virtue of calling super and passing an argument, the circle class's constructor comes into play, and new radius, and it had a this pointer, and it had its new radius parameter within its frame, and its this pointer was pointing at the exact same object that the cylinder constructor's this pointer was pointing at. So now we have two different methods on the stack, two different frames on the stack, each with a this pointer pointing at that exact same object. And what happened was that a 5 went into radius because of this statement right here, radius equals new radius. And Then we're back in the constructor for cylinder 1, since the circle constructor got popped off the stack when it was completed, and the 2 that had been passed in as length went into this dot length. So when we say this dot length, we're following the this pointer to the object, and its length is what gets filled. And then finally the assignment, once the constructors are finished, we're back in the main method. The assignment is going to make my cylinder reference that particular object. Now we're in main, and we're about to call find volume. So we call find volume on my cylinder. So here's my cylinder pointing at that object. We're about to call find volume. Find volume is a method of the cylinder 1 class, and it doesn't have any local variables, it doesn't have any parameters, but it does have a this pointer, right? Because it's an instance method. So it's pointing at that very same thing. And we're going to call findArea, which doesn't exist, remember, at the subclass level. And we're going to multiply that result by length, so we have to call findArea. And there's findArea, which is in the circle class. And it also has this pointer, and it also does not have any local variables or parameters, but it's making use of this radius member variable to calculate the radius. It gets its thing done, and then at that point, it'll be popped. And find volume will complete its calculation and return, and then finally that's what will get printed out. So let's actually run it. So I put a few breakpoints here. I put one in the driver class here in the main method right before we instantiate, and I put one in cylinder 1's constructor. I put a couple of them there, and I put one in circles constructor. And let's go ahead and see what happens when we run this in debug mode. So I'm going to debug it. And here is our stack is only 1 deep. And here all we have is args. We don't even have my cylinder yet because we haven't instantiated and assigned anything. I'll go to here. Here we are in the cylinder 1 constructor. So now we're 2 levels deep. We're about to invoke super. It has a this pointer, which is pointing at this object here. Notice what the object contains. It contains a length. And notice it also contains something that was inherited, which is a radius. And also the method itself has a parameter called radius and a parameter called length. Not to be confused with the member variables of the instance. There's the instance's length doesn't have anything in it yet, and the instance's radius doesn't have anything in it yet either. But we're about to invoke the superclass. We invoke the superclass, and look where we are now, 3 levels deep in the stack. We're about to assign new radius into radius. And there's new radius, by the way, and that new radius, that 5 there, is not exactly the same as what we had here. This is a whole separate location in memory, right? This is in cylinder 1 constructor's frame, and it's called radius, and this is in circle's frame, and it's called new radius. We're about to assign that into radius, and we do. And we can see the instances change. And if I go and I want to look at it from the perspective of this frame right here, we can already see that the radius, this inherited radius of the object has been changed. And now we're back into cylinder 1, back to 2 levels deep. We're about to assign the length. So this dot length is going to get length. So the length of this is going to wind up also being a 2, as we can see. And there it happens. And then finally, we'll be done with that. And if I was to put a breakpoint here in the main, and we're back down to 1, and at this point the assignment has taken place, and you can see that my cylinder, that particular instance, has a 2 and a 5. So here we can see some of the advantages here of inheritance, and the first thing is you don't have to reinvent the wheel. We can make use of pre-existing data and functionality. Of course, we could do that with modularity in general, right? With methods and stuff, we can call methods. But now we can have objects, classes that can inherit properties from superclasses. And it allows us to basically do reuse, what's often called reuse. We had already existing code for initializing the radius, which was the constructor. We had already existing code for calculating the area. We didn't have to do that. We didn't have to make a new variable called radius for the cylinder. We just were able to inherit from the circle. But when we did need to do something special, we were able to do something special. So we had a whole new member variable, and we had new methods that were created to specialize this class. So really you can think of a subclass as being a specialization of a superclass. And perhaps you'll remember that terminology from our database class, because in the database class, when they were talking about supertypes and subtypes, they were talking about the enhanced ER model, this concept of specialization was also discussed, this notion that when we have a particular class, we may want to make specialized versions of it. That's not new to the Java class now. That's something that you were learning about before in database as well. So now I've gone through some of the basics of inheritance. Now let's talk about this notion of overriding. So a subclass can override the methods of his superclass, and remember that's not the same as overloading. What was overloading? Overloading meant you had, within the same class, you had two methods of the same name, or multiple methods of the same name, but they would not have identical signatures. Specifically, they would have different parameter lists. And so at compile time, when the source code is being compiled, we would know what version needs to be called based on the parameters that are passing. The same is true with overloaded constructors. With overloaded constructors, how do we know which constructor is going to be invoked? It depends on the parameters that are being passed. That's not the same as overriding. With overriding, you have the exact same signature in the superclass and the subclass. But those same exact signatures, these are methods that do different behaviors. And so when we're overriding, we start to get into this notion of polymorphism, which we'll dive more deeply into in our next video lecture. So we're going to get a little bit of experience with that here. So it's the exact same signature, but they have a different method body. And you can't have both of them in the same class, but you can have one in the superclass and another one in the subclass. And when you make another method of the exact same signature in the subclass as you have in the superclass, then that is called overriding. So oftentimes we'll do that if we want specialized behavior for the same request. And that's again where we get into this notion of polymorphism. Polymorphism, the idea is you might make exactly the same request, but depending on what this instance is an instance of, you'll get different behaviors. Now, notice that I said when it's overloading, the compiler will know what version to invoke because of the arguments that are passed. That's not true with overriding. With overriding, the compiler can't know because the instance hasn't been created. Is it an instance of the superclass or is it an instance of the subclass? The only time that that knowledge comes into play is when you have an instance and then you're making the call on that instance, and the class, the data type, the class of the instance is what's going to determine which version gets invoked. So now we have another class called cylinder, which is exactly the same as cylinder 1 was, but now it has its own findArea method. After all, the area of a cylinder is not exactly the same as the area of a circle. The area of a circle is basically just the area of the circle. The area of the cylinder, well, it's going to have two circles, one at the top and one at the bottom, and then it's going to have this whole tube thing, this whole cylinder thing involved in it. So there's a lot of stuff going on with the area of a cylinder. And specifically, what we can see is that the area of a cylinder is 2 times the area of the circle, because there's 2 of those circles, and also 2 times the radius, and then times pi, and then finally times length. There's a lot that goes into the area of a cylinder, which is different from the area of a circle. And yet, the area of a circle is relevant in order to calculate the area of the cylinder. So being able to reuse what already exists and specialize it is exactly what's taking place here. And you'll notice that we can take advantage of the Superclasses version by being very explicit and saying we want to call the Superclasses version of findArea instead of calling my own version of findArea. So in findArea here, if I'd have just said return 2 times findArea plus 2 times this whatever, well, findArea would have been calling itself. By the way, there is something called recursion in which a method can call itself, but that's not what we wanted here. We wanted this version of findArea to call the circles version of findArea, and we were able to do that using the super keyword. And similarly for find volume, well, the volume of a cylinder really doesn't require you to know the area of the cylinder, but it does require you to know the area of the circle. And so in both cases, we're making use of the super keyword. So here we see that we've used the super keyword in the context of invoking superclass constructors, and we've also used the super keyword in the context of invoking superclass versions of a method when you have overridden that method in the subclass. So if we're going to look at the UML notation for this, we have our boxes for representing the classes, same thing. And invoking inheritance is done with a line with an empty arrow going from the subclass to the superclass. So here we have that example here. We have circle, which has its member variables, it has its constructors, and it has its methods as well. We have cylinder, which has its member variable and its constructors and its own methods as well. This toString we'll talk about later on what that does. And notice that we're not duplicating, for example, the circle constructor in cylinder. We're not duplicating radius in cylinder. Even though a cylinder instance has a radius, we don't want to put that in our class diagram because just by virtue of having this arrow here, we know that everything in a cylinder is going to inherit stuff from the circle. So we don't have to duplicate that. In fact, don't do that. Don't duplicate this stuff that's in the superclass version in the subclass box. And here we have that sort of thing. So this particular line right here with the open arrow is your typical way of notating inheritance in unified modeling language. So now we could see what happened if we had, instead of using the cylinder1 class in our previous example, we had used the cylinder class, and we wanted to find the area of the cylinder. So in this case, what's going to happen is that the findArea method of the cylinder class is being invoked, which has this pointer pointing to that object. And in turn, it is invoking the findArea method of the circle class, which also has this pointer to that very same object. And maybe it would be nice for us to check that out in Netbeans as well. So I'm going to change this a little bit. And rather than a cylinder, one, I'm going to make it a cylinder. Now, as you can see, as soon as I try to change the data type of the variable, it's not going to like me to have a cylinder1 to put into it, so I have to use the cylinder constructor. So I'm going to go ahead and run this. It's basically going to give me the same thing as we had before, but this time what I'm going to do is when I call the findArea method, we're going to see something else take place. So let me run it in debug mode. Well, here we're in our circle constructor. All this is the same as what was happening before. You can see we're 3 levels deep. Nothing is different here. And now I'm going to, we're going to get to the point of doing the length and the radius and everything. Everything here is going to be exactly the same as it was before. Although I will point out that in this case, with cylinder, let me pull that up. In this case with cylinder, find volume is explicitly calling super.findArea, whereas with cylinder 1, we didn't really have to do that because there was no ambiguity about it. But with cylinder, we do. But what I would like to do is put a breakpoint into my findArea and also put a breakpoint into the findArea of the circle class. And we can then see what's taking place. So back into our main, I'm about to do this print line right here. We call find, oh, well, that findArea was from the volume. Let me just, that findArea call right here was because I had called find volume, which I had called from main. So here we are in main, about to call find volume. We call find volume, of course, that called findArea. Now we're back down to main again. We're about to call findArea, but now we're going to call the cylinder version's findArea. And there it is. And that findArea is in turn, and if we look at variables here, here's our this pointer. Okay. In turn, it's going to call the Superclasses version of findArea. And did I not have a breakpoint there? Let me do that one more time. I think I had neglected to put the breakpoint there, so let me do that one more time. So I'll run it again, debug it. The constructor was invoked. Now we're in findArea from the find volume here. And now we're about to call the cylinder versions of findArea. And in the cylinder version of findArea, we're about to call the Superclasses version. And there you have it. We're 3 levels deep. So hopefully you got a little bit of an idea of how overriding works. And it was the class version of that instance that made it happen. Let me show you one other thing, just to point something out to you. I'm going to make a circle here. I'm going to make a circle. My circle equals new circle. And maybe I'll pass it a 5. And then I'm going to say my circle findArea. And when I get to here, let me just put a breakpoint right here, and I'll remove this findArea breakpoint for now, and even remove the cylinder breakpoints as well. And hopefully I'll just get right to here. We're about to call findArea on, well, there's a constructor being invoked. And there's the findArea of the cylinder being invoked. And now we've created this my circle. And when we call my circle.findArea, I'll go ahead and put a breakpoint in both of them. I'll put a breakpoint here in the circles findArea and a breakpoint in the cylinders findArea. And so when I am here and I invoke it with respect to an instance of circle, shouldn't be at all surprising. It's the circle findArea that's going to be invoked. Now, as I said, this is going to get into polymorphism, and there are going to be a lot of nuances that we're going to be able to take advantage. For example, it is possible to have a variable that is a reference to a superclass, that is a data type that is a reference that is intended to be a reference to the supertype. And yet that reference of the supertype could also point to a subclass instance, as we will see, and that can come in very, very handy, as we will see. And so in that case, even though we are making the call to the method from a superclass reference, it's not the reference that determines which call that's going to be made. It's the instance that's being pointed at that determines which version is going to be invoked. And we'll see that in our next lecture. So just to recap, we used extends to indicate that one class is a subclass of another. We used this to make it explicit whether we're using a member variable or perhaps as opposed to a parameter of the same name. We used super to make use of the functionality at the superclass level, and all of that was done on these examples here. And in our next exercise, we'll actually have another subclass of the circle class, and we'll see what happens with that.